operations on complex numbers. So a complex number looks like this, where one of those parts is real and one is imaginary. Which part is real? Which part of that? The A part. Right? This is the real part. And who is throwing again in my class? That corner over there is trouble. BI is the imaginary part. And so any number that's written like this, we call it a complex number. Okay, it's actually every number that we know can be written like this. The front part of your notes is for adding and subtracting. So when we're talking about operations on complex numbers, our operations are add, subtract, multiply, divide. On the front of your notes, we'll just be talking about adding and subtracting. Multiplication of complex numbers works a little different. So the first thing you want to do is fix any negatives. I made that up. I blended these. Negative radicals and simplify all the radicals first. Okay. Then you add and subtract the real parts together. You add and subtract the imaginary parts together, and that gives you a new complex number. And this little note down here just says, if you're subtracting, be sure to distribute the minus to both parts of the complex number that is being subtracted. And we have an example like that, so we have hands-on practice. You'll see that here in just a bit. I'm actually going to save this problem for last, even though it's usually that's the order we go, is that top right example, but we're going to do it last. We're going to start with this one. It's the babiest of the examples on that side of your page. It does have decimals, but you've got your calculators and your brains and your wits about you, so you'll be just fine. You want to add the real parts together, and you want to add the imaginary parts together. And I want you to go ahead and do that, even though I haven't explicitly told you how. I want you to write down what you think that would look like. All right, so we are adding the real parts together. What are the two real parts? 2.5 and the 4.3, right? So we combine those and we get 6.8. And then the imaginary parts are the other things. Negative 3.1i, 2.4i. That I, when you're combining like terms with I, it's kind of like you would any variable, x, y, or z, even though technically I is not a variable. So when you combine these two pieces, negative 3.1, positive 2.4 is a negative 0.7i. And that's it. That is your answer. One thing I want to point out is this is A plus BI form. The real part listed first, the I part listed second. If the problem is asking you to specifically write it like that, I will expect you to write it like that. Meaning, if you write this instead, it's partial credit. The numbers are exactly the same, but it's not this form. And just as an aside, what I mean by I is not a variable, but works like a variable, I represents a specific value, the square root of negative 1. So it's not a variable in the sense that it represents possible different things. It is one specific thing. Variables vary. All right, that one's good. Here again, two complex numbers. We're going to add them. What's yucky about this problem? Fractions. What's even more yucky about the fraction that we kind of don't like? It's kind of annoying. They're not common denominators. So we are going to talk in a second about adding or subtracting fractions, getting the denominators the same first. But to set ourselves up for success and give us a little confidence boost, let's just do the real number part. What are the real number parts? Negative 4 and 13. What is negative 4 plus 13? 9. Look at us adding complex numbers. 9. Okay. Now on to the fractions. Combining these pieces right here, we only have to do the math on the coefficients. So I'm just going to pop the fractions off of the I for a second and just do some scratch work over here. Negative 5, 6 plus 3i. What's a good common denominator for 6 and 8? 24. Excellent, right? We could go bigger, but why? That's going to make our numbers harder to deal with. So we're going to make common denominators of 24. In this first fraction, negative 5, 6, what do I have to multiply 6 by to get 24? 4. And whatever you do to the bottom, you have to do to the top. Because you're not changing, because this really just means multiplying by 1. You're not changing the value, you're just changing the form of the number. So that gives me negative 5 times 4 on the top, which is negative 20. What about the other fraction? Multiplied by what? 3. Top and bottom. And so that's 9 over 24. And to actually add the fractions, it's different from multiplying. How do we handle the denominator when adding or subtracting fractions? Keep it the same. Okay, we went through all that trouble of making it 24. Let's keep it 24. And then you do the math on the numerators. Negative 20 plus 9, negative 11. Okay. So going back to our problem. What have I left out? I, absolutely. And that is in A plus BI form. A is 9. B is negative 11 over 24. So you survive decimals and you survive fractions. Let's go back to the one with all the radicals in it. Okay. Does anybody need this up anymore? So here we have two complex numbers. This is one complex number. This is another complex number. They're actually not in A plus BI form yet. So back here on the wordy part of your notes, where step 1 says, fix any negative radicals and simplify all other radicals first, that's what we're going to do here. So everything we just did in Kahoot, you're going to do on all 4 of those radicals. You don't need to go further if you don't feel comfortable. All I want you to do right now is simplify each of these things right here. And then we'll catch back up and do the rest of the problem. So here I have everything that can be factored. I used perfect squares. You might have factored all the way using your factor tree. That's fine. So for the first radical, the 4 comes out as 2, leaving me 2 radical 5. In the second radical, negative 1 comes out as I. So that's I rad 3. On the second group, square root of 5 does not change. And on that last radical, negative 1 comes out as I. 4 comes out as 2. So far we've just rewritten the radicals and simplified where we could. That next part of the wordy section of your notes says, note, if subtracting, be sure to distribute the minus to the complex number that comes behind it. This is that. So this negative goes here and here. That's basically a distributive of a negative 1, basically is what that is. So my next step looks like 2 rad 5 minus I rad 3 minus rad 5 plus, because this negative times this negative is positive, 2I radical 3. And I want to be sure everybody is here before I go on. Make sure your signs match, that the numbers under your radicals match. So this number under the radical, this is called a radicand, not a radicant. So I'll be using that word here for a bit. Like terms with radicals are when the radicands match exactly. Not a little bit, but exactly. And we see this when we do math on regular variables. Like, for example, if I have this term 2x, I know I can add 3x to it because they are like terms. The thing after the coefficient, the x's, is exactly the same. But for example, I couldn't add 3xy to 2x because even though they both have x, that y makes them different. Same thing with the radicals. So this is the coefficient here, and this is the radicand, or this radical 5. I can only do add or subtracting with this term when the other things have the square root of 5 as well. Not the square root of 5 and something else to it, just the square root of 5. And there is one other term like that. What's a like term with this? That negative square root of 5, right? So these I can combine, but just to be clear, what number is it? What's the coefficient for this radical? I don't see a number. It's 1, right? Negative 1? Okay. So when you are adding or subtracting radicals, the radical part does not change. You're only doing math on the coefficients. So if you want to write that down somewhere, if you feel like you might forget something like this, a note to yourself, when you're adding or subtracting, you're doing the math only on the coefficient. Okay, the radical parts are going to stay the same. Yes? Yes. Yeah, it's exactly like that. So in this case, when I'm looking at the radical 5s, I would say I have 2 radical 5s here. I'm subtracting 1 radical 5. How many radical 5s do I have left? I have 2. I'm taking away 1. I have 1 radical 5 left. So I did the math only on the coefficient. The radical stays the same. It won't change for addition or subtraction. So for addition or subtraction, the rad doesn't change. For multiplication, it does, but not for add or subtract. So then the other like terms I have are those other 2 terms. A negative I radical 3 and a 2I radical 3. So I said the radical won't change, right? So even if you're not exactly sure how those go together, because it's kind of funky on the coefficients, you at least know it's going to stay a radical 3, because I just told you the radical won't change when you're adding or subtracting. But the other thing I told you over here is you're doing math only on the coefficient. The coefficient is the number up front. Here it's a negative I, and here it's a 2I. So my question to you is, what is negative I plus 2I? Negative 1I, positive 2I makes what? 1I, right? Have a negative 1I, adding 2 to it, that's a positive 1I. Okay, so you're doing the math only on the coefficient part. And me personally, I probably wouldn't leave those 1s in my answer. This is completely fine, but I would do this. Okay. Square root of 5 plus I radical 3. And that's also an a plus bi form, because the second term is the I term. Concerns about that problem? Does anybody need this up still? Okay. Let's talk about multiplying now. Look at this problem over here on the board. Okay, this is a multiplication problem of 2 complex numbers. It looks just like a what kind of problem? No? Not working for you? It looks like a FOIL problem, right? Yes? We're all agreed? I mean, I hope we're agreed. Was I FOIL? Oh, no, sorry. I thought I had asked you to look over here. I thought I had, but This is like my 6th class period of the day. Who knows what's coming out of my mouth? I don't know. So if you were doing a FOIL problem over here, what does L stand for in FOIL? Last, right? So just look at these last terms for a second. We're not actually doing the whole thing. I just want to talk about the last term. If you're multiplying 2i times 3i, what would you get? 6i squared, right? So there's something special about I squared that you need to be on the lookout for whenever you're multiplying. And it's this right here. I squared equals -1. They are equivalent things, and so anytime you come up with an I squared in your math, you will fully replace it with a -1. You're going to substitute it in. And we can see why this is true just continuing from what we talked about yesterday. Yesterday, we learned this, that the square root of -1 is I. And because this is an equation, I can do whatever I want to it. As long as I do to both sides, it's still going to be equal. If I squared both sides, for example, on the left, what happens when I square a square root? They cancel out, leaving me with just what over there? The -1. And then I have I squared over there. So this is just a value that you're going to be looking for. Anytime you see I squared, it equals -1, you can replace it and then do the math that comes from it. So I want you to keep your eye out for that in the next few problems. This very first example doesn't have an I squared, it's just distributive. It's one of the easiest things you're going to do. Go. 3 seconds. Not exactly 3. No pressure. Now with pressure. That's from Nemo, right? You remember that? Nemo? I'm still filming myself. What did you get under now with pressure? You tell me, you narrate, I'm writing, I'm scribing. What did you get? -35i. Okay, good. Thank you. So that was a distributive property. This right here, also kind of a distributive property. There are 3 main ways that we've learned, depending on where you've come from, who your teachers were, what you like, to do this problem. I think of these kind of problems as double distributive, meaning, like we just proved we could distribute, right? This is just distributive twice. It's cover one term up, you distribute the -4, and then cover that term up and distribute the -2i. That's how I like to think of it. Some people do FOIL, first, outside, inside, last. And some people do box method. You are free to do whatever you want. I am going to do double distribute. So first I will distribute -4. Okay. That gives me -12 minus 8i. And then I will distribute -2i. Line up my like terms. You don't have to do that, but I think it's kind of good. This gives me a -12. Combining the i's gives me -14i. And what is happening here that I told you to be on the lookout for? I squared. What am I going to replace that entire I squared with? -1. Now, what's happening between the -4 and -1? Multiplication. Very good. So -4 times -1 is +4. And so I've got one last thing I combine now that I made that an integer. -12 and 4 is -8 minus 14i. That's correct. It is being fully substituted with the -1, the I squared. And I want you to do this last problem. What time are we at here? 25? Do this and I'll pass out your test while you're doing that, because I didn't get to those yesterday. And then while I'm doing that, if I could have a volunteer write it on the board, please, so people can check their work, I would appreciate that. Austin? Parker? CJ? Julie? Emma? Kristen? Aiden? Paulina? Gianna? Excuse me. Vicky? Juan? Shauna? Josiah? Kiara? Yes. Matthew? Sydney? Carolina? Itzel? Bentley? Caitlin? Do I have more than one Caitlin, or just one Caitlin this period? I have two. Wilson, Caitlin Wilson. No volunteers for the last problem. Nose goes. Nathan? Yeah? Can you do it fast? Were you volunteering to do the thing? She might have had it. Oh, I've been recording that whole time. Oh, right. Negative. Oh, no, that's not. Thank you so much for volunteering. I appreciate it. Yes? Yes? Do you find yours? Did you find your phone? Okay. Yes. Thank you.